In this tutorial, we're going to be looking at how to make one-way colliders in Unity 3D. I've seen that on the internet there are quite a lot of tutorials on how to do this in 2D or for platformer games, but there isn't any for 3D. Unity by default does have the platform effect already there to help you with this one, but it's only made for 2D. Today we're going to see how exactly can you do this in 3D. It's actually quite easy, so let's get into it. To start things off, we will create a new project in Unity. I personally prefer creating my projects in URP, and so that's what we'll be doing. You can create it in a standard pipeline, in HDRP, that doesn't matter. I'll just go for URP right now and name it something like One-Way Colliders 3D and create it. Alright, the project now loaded, and to be able to test these things a little easier, we will also be downloading a 3D controller from the web. The one that I found quite easy to use and pretty interesting is the InVector controller, and I will have a link for this one in the description. And all you have to do is just add it to your assets and then open it up in Unity and just add it to your project. Import it actually. I didn't test all this here. I'll just add everything here. Most likely for your project, if it's something that is already in progress, you will not need the third-person controller. I'm just taking this one in order to be able to test the collider and see if exactly it works the way it should. In your case, maybe you don't actually need this one because will not be focusing on 3D movement. We'll be focusing on the collision. But just in case, I will also be explaining to you how to make this one work in your scene. So now that we got the InVector downloaded, now what we have to do is go for the prefabs and get the third-person controller and add it into the scene. If we do this and reset its position, you can easily see that it has the pink textures, which will happen both in URP and in HDRP. So in order to fix the materials, we have to go in the folder of the InVector folder. We'll go in 3D models, in characters, in the only one that we have, in materials, custom, and there we have them all. Select them all, go to edit, render pipeline, URP, and upgrade selected materials to URP materials. And there we go. A pretty cool looking bot we got there. Alright, and now we got the third-person controller, and if we start up the game, but I won't do it now, it can already move. What we want to do, we will remove the main camera from the scene and add the InVector camera, which should be right in the prefabs. We also add it to the scene and tell the camera to actually focus on the character that we have. And now, if we start up the game, we can have our character already moving. And as you can see, the walls have no colliders, but we will fix that. Alright, so now let's focus on the colliders. Firstly, I want to remove the wall here, the brown wall, because it actually doesn't really fit what we are trying to do. We want to make it so that the walls are clearly visible, and so we will just remove that one if it would only allow me to do so. I'll just unpack it and now remove the frame, and we'll now just duplicate the walls here. Actually, these are some pretty nice walls. Actually, I'll just keep it as simple as this. I'll just remove the one in the back there and duplicate this one. And we put it right here. It really doesn't matter, this is just for display purposes. Again, in your game, you can do it just the way you want it. It doesn't really matter. All right, now we got both walls here. All right, so now that we got the both walls set up, now we will have to work on the actual script that we want to work on. So we'll create a new script and we'll call it one-way box collider actually, because what we'll be working on is only a box collider. If you want to make a one-way collider that is, I don't know, a cylinder, a sphere, I'm not going to be tackling on that one, even though it should technically work pretty much in the same way. Alright, so now let's start with the very basics. We want, as you can see, the class already has a name box collider, so it always needs a box collider attached to it, and it will most likely be on this very object. It must be on this very first object. So we'll add the require component uh, attribute with the type of a box collider. By doing this, unless you already know, so this is not mandatory. Alright, this is just for for ease of access and ease of use actually. So this one, what we'll do is whenever you add this component to an object, or if it will also add a box collider to it. So this comes very handy. You will not have to worry about referencing the box collider accordingly and all that. It will do it by itself. So now we will add a private new box collider called collider. Now you may be wondering what is the meaning of this new here. Well, Unity by default has some deprecated variables in mono behavior called collider, but you cannot use it. So if I just put a new one, it pretty much overrides the old deprecated variable there. You can just call it however you want. I just want to keep the names quite simple. What we also need, which is pretty handy, we want to know what direction the wall needs to be entered from in order to actually be to not be solid. Like for example, for a platform, you want it uh, to be solid when you come from above, but not solid when you come from below. So for that, we will need a field that keeps in mind the direction for this. So we'll call it to be a vector3 called entry direction. And by default, it will be up. What I also want to do is, but again, this is not mandatory, but I will use it, is want to know if this direction is actually a local direction or a global direction. If you don't know what this actually means, if it is a local direction, it means that the direction you put here is relative to the rotation and position of the main object here. I will show you further on this topic when we go back into Unity. So I will add a boolean called local direction, and by default it will be set to false. And now, as you can see, we have the collider here, and we do not have a reference to it. So it will always be null. So how do we fix this? Well, in Awake, we'll simply do collider equals get component box collider. And it will get the component of type box collider that is already on this object. And we know it will be on this object because we added this attribute here. All right, now let's get back into Unity and see how it goes. Now on the walls that we want to use as one-way colliders, we'll select both of these and add the script that we just created. So one-way box collider. When we do that, as you can see, it already added our script and the box collider. Right now, both of these walls have the entry direction set to 1, which is not exactly what we want because these are some walls. If you want to make a platform, which is most likely what you are after, then this is fine. And actually, in order to make this clear, I will also add a platform here, so it's easier to understand what exactly we're working on. So I'll just duplicate the platform below here and put it as a ceiling here. Right there. And we'll also add to this one, in that case, a one-way box collider with the entry direction of 1, which means now if you jump from here, you will be able to pass through the ceiling, but you won't be able to go back. And for these walls, we want to know actually the entry direction, what exactly it means. Because right now we can mess with these values here, but we don't actually know what the value means. So we will use some gizmos to draw that for us. So we'll go back into the code, and for that to work, we will go on draw gizmo selected. Again, this is not this part is not important. You can this is just for ease of access again. I'm pretty sure I said that phrase quite a lot during this recording, but well. All right, so right now what we will do, we want to make two lines here. We want to draw two lines. I want to draw a red line facing the direction that you cannot come from. So for example, for a platform, the area above the platform, which is solid, will have a perpendicular red line on it because you cannot come from that direction, and from below there will be a green line perpendicular to the platform, which will make it quite clearly visible that you can come from below, but you cannot come from above. So what we will do? Gizmos.color equals color dot red, and gizmo.draw ray from our current position. Actually, yeah, from our current position. Transform that position. And now we also want to know the direction that this one is facing. And the direction will be actually the entry direction. And right now, as you can see, we are not using this variable, but I will show you exactly in a second what it means. And now we'll pretty much do the same thing for the green color, for actually the actual entry direction. But this one will be in the opposite way. So it will be minus entry direction. Let's see how it looks. So now, as you can see here, if we go especially on this one, the platform, you can see that up here, actually let's just hide the arrows from Unity. As you can see here, the platform has up here a red line and down a green line. And as I said before, this just indicates which way is passable and which one is not. If we change the entry direction, for example, but we want to change it for this one. Let's change it for the wall, yeah? If we go for the wall, we want, right now you can easily see that it also is meant to come for you to enter it from below and not from above. But we don't want that to happen for this wall. We want it to actually, we want you to be able to, let's say, go this way, but not that way. To do this, we'll just change direction. Let's say maybe one on the z-axis. Let's see what this means. For some reason it is not, the line is not drawn, or is it? Yeah, now it's fine. It was not on z-axis, it was on the x-axis, yeah. So now, that's pretty much the opposite of what we wanted, -1. So yeah, you can come from this direction, but you cannot come from the other direction. And if we do the same thing here on the wall, for this one, we will definitely need to do it on the z-axis. And for this one, I want you to be able to join the room from the exterior, but you cannot go through this wall or from the interior. And you can see the lines here. However, you have to keep something in mind. As you can see, right now, if I rotate this wall, the entry direction and exit direction remain the same. And why is that? Because right now the entry direction is a global direction. And we want that if I tick the local direction, we want that the entry direction will also rotate along with the wall. To do that, we will need to make a conversion here. So back into the code, we want to make it we want to make this direction convert from local space, from local space to global space. And how do we do that? Well, that's a quite easy question. So we will just go for, firstly, here in the gizmos, we'll first calculate the actual direction. So we'll make it a vector3 direction, and we'll first set it to, I don't know, default, which means that we didn't actually give it a value. So actually, we can just type nothing here. So we'll check here. If it is a local direction, in that case, the direction is equal to transform dot transform direction, which, as you can see, what does it do? Transforms direction from local space to world space. And in the parentheses, we'll just put the entry direction dot normalized. We want it to be normalized to ensure that the the input values in the inspector are always normalized, because we cannot actually check if that's the case. All right, so that's this one already converts the direction to be a local direction, and if it is not, then direction simply is the entry direction. So here we'll just replace both with direction, and we should already have this easily clearly visible in the game. Let's see. Right now, if I rotate it, right now you can already see that the entry direction is no longer, the gizmos are no longer visible. And why is that? It's because it is a local direction now. See, now I made it back to -1 on the z-axis, and if I rotate the wall, the direction also rotates along with the wall on any axis. And that obviously applies to pretty much everything that we made around here. This wall right now has the directions like that. If I tick the local direction, it pretty much stays the same because this one is done right. And it can also rotate with these. This one up here can also be set to local, and now we can also rotate and have its direction set correctly. All right, now we have, we can clearly see what is happening here. Now it's time to get to the actual code. What we want to do is we want to make sure in the beginning that the collider is a collider, not a trigger. So we'll make it like collider is trigger equals false. This is just for safety purposes. So again, you can just leave it out if you want to. And what we want to actually do is, there is a method in Unity, unless you already heard about it right now, which is in physics dot ignore collision. And as you can see, what does this one do? It pretty much makes collider 1 to ignore the existence of collider 2. They both will no longer be able to ever collide one with the other. And that's pretty much what we'll be going for. I've seen some posts on Stack Overflow that when some people ask this question of one-way colliders, they would just say that enable and disable the collider based on the player position, which is fine. That would also work. But what if you actually wanted for more objects to pass through it that way. Because if you just do it relative to the player, as this post suggested, then that would work, but only for the player. If there are multiple objects, then it wouldn't work fine. But with ignore collision, this one definitely works. So now how exactly do we do ignore collision? Well, we have to keep in mind, ignore collision will do one thing, will make it that they no longer detect any collision between the two. So if, for example, you have the on collision enter method here, or on collision state, depends on what you're aiming for. This one will no longer be called when this one will no longer be called when two objects ignore each other's collision. So we have to make sure that what I initially made for this one was that I made a collider that automatically disables itself with ignore collision, not completely disable, but it just ignores the other one when the player comes from the right direction. But that's not exactly what we want to do now, because if you do that, then it works once. It allows the player to go through it once, and then it will never ever actually know about the existence of the player because it can no longer detect if the player actually comes through. So what I thought about, and seems to have worked for me quite fine, is actually make a trigger around this collider, which is pretty much exactly this collider, but a little larger. So what we'll do is private box collider collision check trigger, as I call it. And this one also has no reference, and it will also not go with get component because we don't want to add another collider to the object. We will actually do that by ourselves in the awake method. We'll just say collision check trigger equals game object dot add component of type box collider. What this does, it adds a new box collider component to the object, and we now have a reference to it. But it is uninitialized and it may not function the way we want it, so we have to initialize it ourselves. Collision check trigger dot size equals to collider size. So we want it to be the exact shape of the original collider, but with its measurements a little increased. So collider dot size multiplied by, and we'll now make a variable which through which we will tell the game how large do we want these triggers to actually be compared to the collider. You will understand exactly what these colliders mean in a second. I just want you will see exactly what they mean. So we'll just say here private float dot trigger scale, and by default I should go for 1.25f. And we can also make it a range, so it's easier to set the values, and we'll make it between 1.0f and 2.0f. We do this because we definitely don't want to be the trigger to be smaller than the actual collider. That would most likely make the object, the collision, to work a little weird. So it should always be the same size or larger than the actual collider. All right. So let's go back here and collider.size multiplied by trigger scale. Then we want to make sure that the center of the collider is the same as of the trigger is the same as the colliders. So collision check trigger dot center equals collider dot center. And also we want to make sure that this one, the collision check trigger, is a trigger. So its trigger equals true. And now if you go into the game and start it up, let's just pause it and look into the scene. You can easily see that all these objects now also have a trigger added onto them that's a little larger than them. You most likely can see it easier here on the ceiling. And and it is marked as a trigger. And now you may ask, what exactly will we do with this magical trigger that I'm talking about? Well, this trigger will actually be the one to detect if the player is close to the object and what direction the player is actually coming from. So again, we want that the player, if he's coming from a certain direction, to be able to go through the wall. But if it comes from the opposite direction, it will not be able to. It will collide with the object. So what we will do, we will go for on trigger stay, and we'll have to do a few checks here. So firstly, we want to simulate a collision between the trigger, in our case, the trigger and the player, or not player, so between the trigger and the object that's coming into it. So we go to if physics dot compute penetration, and now we have to tell it exactly what collider is coming and how is it rotated and what its position is. You might wonder right now, why do we have to simulate a collision if we already have it through the trigger on trigger stay? Well, with on trigger stay, or actually any pretty much collision that you can make through the Unity function methods, you don't actually get one thing, and that is you don't get the direction that the other collider is coming from. Maybe I'm wrong on this one. I'm pretty surprised that this is not already built in Unity. So if I'm wrong, just correct me. I'd be happy to hear what you want to say. But this is the way that I found, and let's just see how it works. So now we have to type in the values of the first collider, which are collision trigger, check trigger. We want to simulate a penetration, which means a collision between the trigger and the other collider. So collision check trigger, its position, which is our transform dot position, and its rotation, which is transform dot rotation. And now we have to type these for the other object, which is the collider that just entered on the trigger. So we will do a other, which means the other collider, its position, so it's other dot transform dot position, and other dot transform dot rotation. And now we also want to keep track of the direction that this is coming, the direction of the collision, which is out vector 3 direction. And sadly, we also have to add another one that we'll not be using, which is out float penetration depth. We'll not be using this variable, but we'll just have it there because it's a must, sadly. And what exactly does this do? Why is all this inside an if? Well, this function, we will simulate the collision and will return true if the collision actually happens, which will always happen, but we just have it here. It always happens because we are on trigger state, so we already know that it entered. All right, so if this happens, we want to check the difference between the entry direction and the actual direction that the object is coming from. And how we will do this? Well, we will need to use the dot product. So we will do a float dot equals vector 3 dot entry direction and direction, which is a collision direction. Let's actually rename it collision direction. The dot product will actually multiply the vectors, and if you do not know, if the dot product is less than 0, then it means that these two directions are in opposite, are facing opposite ways, or one relative to the other, which would mean that we are coming from the wrong direction. So if dot is less than 0, which means opposite direction, passing is not allowed this way. In this case, we will say physics dot ignore collision. We want to ignore, if this is the case, we want to make sure that we are actually not ignoring the collision. And how do we do that? We use the ignore collision, but we also want to make sure that we actually enable the collision between the two right now. So we just say ignore collision between the collider, which is actually our collider, with our collider and the other collider, and make sure that it is set to false. So we will no longer ignore this. And we actually ignore it in the other case, where the dot product is larger than 0, which means that both the entry direction and the collision direction are facing the same way. In which case, we'll just say physics dot ignore collision collider other true, which means that we want those to ignore each other's collision. And now that pretty much should do it. However, the entry direction right now is also not, doesn't care if it is a local direction or not, so we'll just have to do pretty much the same thing that we did here. So we just copy paste it from there, go here, paste it, and we'll just use, instead of entry direction, we'll just use our direction here. And now if you go into the game, this one should pretty much already work. Now let me just move my player away because it's a little too close to the wall. And let's see if it actually works. If you go this way, we can go through it. If you go now back, we can no longer go through it. As you can see, it's completely solid and I cannot go through it. But as you know, on this one, now we should be able to pass through it. Can we? Yes. Can we go back? No, we can't. What about the platform above? As you can see, I can pass through it like this, even though I'm not, let's say, tall enough. I cannot jump high enough to actually pass through it. So let me just increase our jump height, which should be somewhere around here. Let's make it to, I don't know, 7. And now if we jump, we can go up, but we can no longer fall down, even though you can see that we have some problems with the animation, but that's definitely because of the invector. In your case, it shouldn't be a problem. Yeah, it's just a problem with how invector handles animations. But as you can see now, it works. So that should pretty much do it. Now, I want to make things a little clearer unless they were already from before. So, how exactly does this work? So let's see. If I press now on play again, let's just go into the scene and look at our wall. Yeah. So right now, if the player comes close, the player comes from this direction, whenever it whenever it gets nearby the wall trigger, the trigger just checks, is the player coming from the right direction? And if the player is coming from the right direction, then the physics engine will ignore the collision between the two objects. However, if the player is coming from the wrong direction, then the trigger will inform the collider to actually no longer ignore collisions between the two, and so the player is not allowed to pass through. And again, you may ask, why Don't we just why do we have a trigger and a collider? Why can't one collider actually handle all these? Well, as I said in the beginning, this is because on trigger state will always happen no matter if we do ignore collision or not. If you would have done this to the actual trigger, then it will no longer be able to check further away, and the bug that happened in the beginning will repeat. So that's pretty much how it works, and it's pretty useful to me. And now there can be some improvements done around here and there, but for the most part, this should actually do the job. Now you can also rotate all these walls. You can pretty much do them the way you want. And you can also increase the trigger scale if you want to. But I'm pretty sure that 1.25 should do the trick in most cases. You can mess around with the trigger scale the way you want. I just made like this for ease of access and all that. And yeah, that should do it. Now we can make a platformer game and it should be quite fine. Well, what can I say in that case? Thank you for watching. Hope you found this video useful. Definitely let me know if there could be any improvements made to the code and also the video as a whole. All this video went unscripted unless it was already obvious. And so if you have any suggestions, I'm open to them. Thank you for watching and I'll see you all in the next one.